Hey, what's up YouTube? In this video, I'm first going to showcase a new blueprint system I just released on my Patreon, a neat little radar system. Then I'll do a technical breakdown of some kind. I'll try to explain how it works in case you want to build something like this on your own. Alright, let's jump right into it. So it's quite a feature-complete system. I'm quite happy with it, to be honest. Let me first briefly show you what it's capable of. At the top of the screen is displayed a small radar widget showing cardinals: north, east, south and west. By default, the radar is configured to have a field of view of 180 degrees. And right now my camera's field of view is 90 degrees, right? Which means if I aim towards the north, the east and west cardinals are precisely located at each extremity. You can, however, configure the radar to have any field of view, like say 360 degrees. Cool, I'll keep it at 180 degrees though. Now the camera's field of view is also taken into account, meaning if I go from 90 to 120 degrees, I can see more of the 180 degrees range the radar has, so I get to see both the east and west cardinals at the same time now, if that makes sense. Next, the radar can have modes. I have set a debug key in this demo project to change it, its tab. So by pressing the tab key, I can switch from the default mode to some kind of combat mode and maybe a stealth mode, and then back to default. These are just examples. You can of course change this and create your own modes. Alright, that's the basics. Let's display some stuff on that radar. Here's the first example. This actor adds a thing on that radar. I called that thing a marker. So if I move around, you can see that the marker moves on that radar to point to that actor. And it does so even if I change the camera's field of view. Cool. Next example, same thing, but the actor moves, and you can see that the marker moves with it. Multiple actors are of course supported. Note that markers can be colorized per actor. Next example, this actor has a sphere trigger and the actor is simply destroyed if I go inside it. That's to show you that this actor's marker is automatically removed from the radar. Next example, let's make use of radar modes. This actor's marker is configured to only show in combat mode, as you can see. It could also be configured to show in combat or in stealth mode or in any mode really. Moreover, the system has a simple target marker mechanism, and I have set a debug key to show that. See, I'm highlighting a random marker. So that could be tied up with your combat system or camera locking system and whatnot to highlight the targeted enemy's marker or something. Next example, it's super easy to add and remove markers upon certain events, like here, when overlapping this sphere trigger. Here's another cool feature. Markers displayed on the radar can be displayed on screen as well for a certain duration or infinitely. See, these markers are displayed on screen for 5 seconds and then disappear. And if I keep tapping the key I set for that action, I reset that timer and widgets keep being displayed for longer and longer. That feature can also be tweaked to only display markers of certain types, enemies, quests and so on. Very cool. Last feature, you can add custom markers. Again, I'm using a debug key just for the demo, and that should spawn a custom marker somewhere around my pawn. See that exclamation mark on the radar? Seems like that marker is pointing to something around here. Cool. Again, it's just an example of the things you can do with the system. And that's pretty much it regarding features. I reckon you can cover a lot of use cases already. Track nearby enemies on the radar, put quest markers on the radar, put custom markers and so on and so forth. From a user perspective, I believe the system is also very easy to use. First, there's a controller component you need to add to your player controller. Emphasis on player controller. That's what the system expects and that's that. Now this component comes with a few settings. They all are pretty straightforward and well explained in the tooltips, so I won't bore you with the details here. That component also comes with a few functions and most are showcased in this demo project, so I won't go into too much detail here either. You can activate and deactivate the radar, get and set the radar's mode, display markers on screen for a duration, target a marker, and create and remove custom markers. The only thing you really need to pay attention to is that components created radar widget event. You see, the radar system isn't responsible for putting the radar widget on screen. That's your responsibility. For instance, let's assume I have some kind of game widget and I want the radar widget to be displayed here. Well, I simply added a named slot called radar to my widget. Next, I implemented that component's event. Here I'm just creating that viewport widget of mine. I'm getting its radar slot, and I'm setting its content using the radar user widget sent by the system via this event. Okay? By the way, you receive this radar widget whenever the radar is activated. And that's the only thing you need to implement on your own. It gives you complete freedom over the radar widget, where you want to display it and so on. Moving on, next there's an actor component. It needs to be added to actors you wish to track on the radar. So this demo project is bundled with a few examples. For instance, here's a super duper simple actor. I simply added that radar actor component to it. Now that component comes with a few settings. The image to display on the radar and the image size. The image to display on screen and its size. Keep that empty if you don't want this marker to show on screen. Next, you can specify if that marker should be displayed when the radar is in a certain mode, maybe in all of them, maybe just in combat mode or something. Next, there's a markers type. This, for instance, can be used to filter markers that you want to display on screen. And finally, there's a markers color. That's for the settings. Regarding functions and logic, there's very little to handle. All you have to do is to get the player controller in one way or another. The most simple way being this getPlayerController node. It comes with a few gotchas regarding multiplayer, but for most use cases this should do the trick. Then get its radar component, make sure it has one though, and then call its startTrack component function when you want to display this actor's marker on the radar. Just have to forward this actor's radar component. Then call the stopTrack component function to remove the marker from the radar when desired. That's it, super simple. The system handles everything else, especially in case the actor is destroyed or something. It's all taken care of. Now, please keep in mind this is a blueprint solution. It's not necessarily a complex blueprint, but there's still a decent amount of logic that needs to be ticked, so it won't scale too well performance-wise. Track 100 actors and you'll start to experience a dip in performance. That's just the downside of using blueprints. Now, I believe the system is elegantly built, and so you should be able to port it to C++ with relative ease, at which point performance shouldn't be too much of a concern anymore. There could also be optimizations to do regarding widgets, like invalidation behavior, caching and whatnot. It's really not my area of expertise. The way I see it, this blueprint system is a very decent starting point and could do the job well enough depending on your game, if you don't go crazy with the amount of actors to track. Alright, that's it for the demo. Time to get technical and see how it was built. So I went for a sort of monolithic architecture to keep things easy to understand. What do I mean by that? Well, that controller component handles pretty much everything, so if you're looking for a feature or something, look in there. See what I mean? That other actor component is almost empty. It has no function, no event, nothing. Well, one event, but I'll get back to that later on. That actor component is however used for a couple of things. One is to own settings, of course, so you can tweak things per actor, very handy. 2, so the system can point to that component's owner, the actor, right? To get its location in case it's moving or things like that. 3, to cache pointers to 2 resources. The first one being the marker itself, that little image displayed on the radar, and the second one being the actor owning the widget component used to display that marker on screen, in case that happens. And that's it for this actor component. Now, on top of these 2 component blueprints, there are also 2 user widget blueprints, but again they don't do much, if nothing at all. One widget is, of course, the radar widget. It has no functions and no events. It exists just to contain a few widgets. Images for the radar bar itself and its 2 endpoints, an empty overlay that's to later contain the markers, plus an extra overlay to display the radar mode using images, combat, stealth, whatever. Feel free to change any of these, by the way. So yeah, again, that widget doesn't contain a lot. The main takeaway here is a marker overlay. That's what contains the markers, and it's a public variable so other blueprints can have access to it, okay? That's it. The second user widget is even simpler. It's a user widget meant to be used in a widget component to draw markers on the screen. So it just contains an image really. Again, no logic. Hence the monolithic design I mentioned earlier. Everything is done in that one and only blueprint, the controller component. And it's arguably not even that complex. It has a few settings, some private variables, a couple of functions, and a begin and end play event that are both pretty straightforward, as well as a tick. So where do I begin? Well, at the beginning, I guess, on begin play. If that setting is set to true, the radar system is right away activated. Let's take a look. Again, this component expects to be owned by a player controller. So first I get this component's owner, cast to a player controller, and cache the reference so I don't have to cast twice. I don't see any reason for this component to change owner. Next, keep in mind the radar system can be activated and deactivated at will. Could be that a cinematic is triggered or something. You might not need that radar to tick at all times, right? So activating the radar system might actually reactivate it, meaning it may already have created the radar widget. If not, I create it and set its width. Next, if created, I also create the cardinals, the north, east, south and west texts. As you can see, those are at first a map, so you may create more than 4 cardinals and specify the angle, quite straightforward. So for each user specified cardinal, I create a text object and configure it. Font, color, text, pretty basic. Next I cache the text widget in a map to keep its reference around, but also to keep in mind its radar angle, if that makes sense. Next I get the radar widget I previously created, get its marker overlay to add the text to it. And that's it, so the text position isn't set yet. This is just to simplify this blueprint as much as possible. You see, cardinals visibility and position are both handled during update, so I just have to wait for the next update to compute this text visibility and position. Hence why this text visibility is set to hidden at first, so cardinals don't show at some default position for a single frame when just created, if that makes sense. That's the widget creation part. Next I broadcast a message to send that widget to whoever's listening. That's what allows you to listen to this event in the player controller, to then add that radar widget to a widget of yours. And at this point the system is deemed active. Next, I feel like it's too early in the breakdown to go over that function. That'd just be confusing at this point, so I'll get back to that in just a moment. Anyway, last step, I enable tick and that's the activation. The deactivation process is even more straightforward. I just disable tick and remove the radar widget from its parent if desired, and that's it. Next, let's go over the update function called onTick. First, I ensure references are all valid. Radar widget, cached player controller, controlled pawn, and the camera manager. Next, I get the controlled pawn's location. That'd be your character, right? Using the controller's camera manager, I also get the camera's FOV and yaw. Turns out that's all I need to position markers on the radar. So first, cardinals. I simply loop through them all to convert the angle they are paired with, remember, to a normalized delta angle. Meaning if I look towards the north, the east and west cardinals should have a delta angle of -1 and 1 and north 0. Assuming the radar's FOV is 180 degrees and the camera's FOV is 90 degrees, okay? That's all this does. Which means I just need to multiply this delta angle by the radar half width to get the marker's position on the radar. And if not within that -2 to 1 range, hide the text widget for that cardinal. That's it. Same principle for other markers. So basically, when the user calls the start track component function, the provided radar component is added to this array, pretty much. And each radar component is supposedly attached to an actor. Thus, I can get the actor it is attached to via the getOwner component function. So on tick, I loop through the radar components in reverse. That allows me to safely remove entries from the array in case something went wrong. It's important to keep this array clean and get rid of invalid references. Maybe an actor or a component was destroyed or something, who knows, right? Anyway, if valid, I get that component's image marker, get its owner, the actor, to get its world position to compare it with my pawn's world position and get an angle. That angle again is converted to a normalized delta angle to compute this actor's marker position on the radar. That time it's cloned though to always remain visible on the radar, unlike cardinals. And that's it for the tick event. So it's not a lot of logic, but still, do that on a loop many times and the cost becomes noticeable real fast. Blueprints, you know. To summarize, upon radar activation, I create a radar widget. It owns an overlay to add markers to. Next, I create a text for each cardinal to display on the radar and cache that text. And it's added to that radar overlay. Next, on tick for each text, I set the text visibility and position on the radar. And that's done based on the angle each text is paired with, right? I also loop through that array of radar components to do something similar, just that unlike cardinals, I'm working with an image, not a text, same but different. And the angle needs to be computed on the fly based on the actor's position relative to my pawn's position. And that's the gist of it. So at this point, there are still two unknowns. First, where is this image coming from? And two, how is that array populated with radar components? Well, let's take a look at this start track component function. First, if the provided component is valid, I make sure it's not already part of that array. If not, I go ahead and initialize that component. Meaning, first, there are a bunch of safety checks. The component itself, the radar widget, and its overlay. Next, this radar component might still reference a valid image for any reason, so I might as well recycle it. Else, I just create one and I make sure to cache it in that radar component's variable for later access, like here on tick. Next, I configure the image based on this component's settings, texture to use, color, size, and so on. And then I simply add that image to the radar widget's overlay. Finally, all is good to go. I cache that radar component in that array, and that's how it's populated with components. And that's also how each component knows which image belongs to it, if that makes sense. The rest happens on tick, like I previously explained, where I get that component's image reference to compute where it is located on the radar. And you know what, that's pretty much it. Now I might need to remove a marker though, and actually there are two different cases. First, the user might simply call this stop track component function. In that case, I get that component, get its marker image, if it has any, and remove it from its parent, meaning from the radar overlay. Then I simply remove that component from the array. Ignore this, by the way. And that's how that radar component's marker is removed from the radar and how it is removed from that array. Second case, this component is destroyed. Maybe the actor owning this component is destroyed, maybe only the component is, I don't know, and the system has no way to know that either. Very tricky. Now, to solve this, there are many solutions. Some I'd say are more elegant than others, some are more complex than others, and some I suppose are more bulletproof than others. I tried different methods, to be honest. In the end, I think the most simple solution is to just let the radar component notify the controller component when it is destroyed. That's why the radar component has this tiny bit of logic, that endPlay event. It can dialogue with the controller component because the controller component gave it a reference to self when that radar component was last initialized. That way the system can still remove this component if it's destroyed like it normally would. And that's how the system works in a nutshell. Now there are still a few features here and there I haven't yet explained. Remember that activate radar function? There was this function I kinda skipped through. Well, I implemented what I called an initialization stack. I'm not sure it's an elegant way to solve the issue it's meant to solve, but whatever. You see, when the user calls this start track component function, things might go wrong, especially on begin play. There could be race conditions happening because the order in which begin play events are called is somewhat undefined. That's not technically entirely true, but for the sake of the video, let's pretend it is. So an actor might call this start track component function on begin play before the system is activated on begin play. Thus, there might not be a radar widget yet, there might not be an overlay to add markers to, and so on. You get my point. But still, the user called this function, so I probably still want to track that component as soon as it's possible. meaning if this radar component can't be tracked right away for any reason, it's added to an array, and that leads to this function being called nextTick. And all that function does is a reverse for loop on that initialization stack to call that same initialize function and retry again. If it succeeds, the radar component is removed from that array and the system keeps trying as long as the array isn't empty. And that's the initialization stack. Last feature I haven't explained. How are widgets displayed on screen? Well, it's quite easy actually. Again, I'm working with an array of components, and so for each component I can get its owner and thus its location. Thus, the idea is to simply spawn an actor that owns a widget component at that location. And maybe even attach that actor to that owner to support movement. Next, set that actor's lifespan to draw that screen widget for a certain duration, and that's the idea. There's a tiny bit more to it, but I'll let you take a look at the project for the proper implementation. Voila, that's my radar system. Files are available as a tier 3 reward on my Patreon, as well as many other cool educational projects and demos. Feel free to leave a like and subscribe to my YouTube channel if you liked the video. Also, let me know in the comments below if you'd like some C++ videos. I'm kinda wondering if that's something I should do. I feel like this radar system, for instance, would be the ideal candidate for an introduction on how to port blueprints to C++. But yeah, I'm not sure if that would interest a lot of people. Plus, providing long-term support for C++ example projects is a pain in the butt, unlike blueprints where you don't care. Blueprints tend to just work from version to version, so there's not a lot of work to do regarding maintenance. C++? Not so much. Anyway, that's it. Thanks for watching, and thanks to all my patrons for the incredible support. Stay tuned for the next video, take care of yourself, bye bye!